So do I need to continue or start from the first point?
Could you please start from the beginning?
First point? Yes.
Okay. Okay, I will close those. So first, if you open the PDI software, you can see a welcome window, and you can say in the left. Actually, we have the software has provided some functions for conduct the ETL tasks, and first we need to create the star schema, include the fact table and the dimensional tables based on the data source, right? So in order to complete these tasks, we need to create several transformations for each table. For example, first let's click the file new and create a new transformation. And in this transformation, we want to create a dimensional table using the customer file. And first, we need to input the file, and you can click the input folder and drag the CS file input into this transformation. I see some. So maybe I will answer your questions after I introduce this software. So after that, you can double click this button, and in this window, you can set the properties for this input function. For example, you can change the step name into the customer sales file input to give more information about this step. And the next, we need to select the file path, and you can click the browse button to select a file. And and you can select the file in your computer. For example, my file is in the here. So in here you can select those sales files. Here we select the customer export.csv file. Click OK. And we can say that this file, the fields are separated by the comma. So this means the delimiter is right. And you don't need to modify other selection, other options, except this. You need to uncheck the lazy conversion, and then you need to get the fields. Click this button, get fields, and input the number 0 to obtain all the fields, and click OK. And after that, you can say that those information are shown in this window, and you can modify those values. For example, in the customer first name, you can modify the length to 30 to modify to accommodate future changes in the data, and of course this one, and check the types of values, and then you can preview the data by clicking the preview button, and we can preview, for example, 10 rows, and click OK. And after that, you can say that I have opened a exam prev date window. In this window, you can say I have actually get 10 rows from this file in my local computer, and then click close, and then click OK. And by this step, actually, you have input a CS file into this transformation, right? And next step, you need to transform or convert these tables into a dimensional table. And in order to do that, you can click the data warehouse folder, in the designing tab and drag a dimension lookup update function into this transformation. And you need to connect this output as an input for the next step. To do that, click on this button and click this this right arrow. This means you can click on the input and connect this to the output and click the main output step. And next, we can double click on this button to set the properties for this step. For example, you can change the step name to customer dimension lookup update, and make sure that this update the dimension is checked. And next, we need to create a connection to the database, to the Postgre database. This is because we want to store the dimensional table in the PostgreSQL, right? So we can create a new connection by clicking this new button. And we will open a window called database connection. In the connection, you need to you can specify a name. For example, we can guess localhost. PG and the order. And in the connection type, let's select the PostgreSQL here. And you need to input some values about this connection. For example, the host name is, I guess it's localhost. If you install your database in the local computer, it also can be IP address if you use a remote server. And the database name is a database that you want to connect. For example, here I have connect a database called order example, and the username is a user of this is owner of this database, and you need to input the password and then click test. Okay, sorry. Postgres. Let me check. So you can say that I have created a database called order example here in the PostgreSQL. So I want to connect to this database. And you can say that I didn't have any tables at this moment, right? And I don't know, maybe I need to change the database name to order example. And then click test. If you can say this window, this means you have connected this database successfully, and it shows the connection information. And click OK, and then click this OK button. And next, you need to specify the target schema, and click Browse, and select the public schema. So the public schema means the schemas right in the database. Actually, this public schema is the default schema in PostgreSQL. So actually, we select this public schema to store the data. And you can specify the dimensional table name for this. And here we will set the custom dim table. Custom dim as a table name for this dimensional table. And next, you need to set the field in stream and the dimensional field. The field in stream means the field name in the original data source. Let's go back to the original data source. Here you can say that this is this is a key for this customer file. So here you need to set the customer ID here in the field in stream column, and in the dimensional field, this is a dimensional key that you can speak.
You have a typo. It's customer ID, not customer ID.
Oh yeah, thank you. Yeah, and in the dimensional field, actually you can specify any name that you for example you, but we will set the same name as the field in the original source, right? And it is very important that to set the technical key field here, and this is called the surrogate key in the dimensional database in the data warehouse. If you can remember in the second week, actually we have learned the surrogate key. So surrogate key is generated by the system. It has no business meanings. It was only used to as a identifier for each tuples in the dimensional or factor tables, right? So it is very important to set the surrogate key in the data warehouse because because your original data in the OLTP database may be changed, and if you don't use a surrogate key, it may overwrite the original data. Yeah, and if you want to keep a track of the history changes, you will lose the information. So you need to set the surrogate key. It is also called the technical key field. Here we will set as custom dim ID. So this custom dim ID will be used as in the factor table and the dimensional table. But in the dimension table, we will have two keys. First is the surrogate key, and the second is the original business key or the natural key. So then we need to then you can just let all the same division and the data from data 2. I will explain what are this means. And next, click the fields tab right beside the keys tab, and click get fields. And in this in this window, you can say you have gotten all the fields except the customer ID fields, right? If you can say the customer ID fields in this window, you need to delete the fields. But I think if you first set the keys fields in this and then select and then get the fields, you will not get the customer ID in this table. And you can say I have get the other fields except the customer ID. And now you need to click the circle button. You can say that this will open a simple SQL editor, and this is a create table SQL this is SQL for create table called the customer dim table, and then click execute. So after you execute this SQL, it will create a table in the database that we are connected to, and click execute. And you can say that as 3 SQL statements are executed, and then click OK, and close this window, and then click OK. So now let's go back to the pgadmin or to check whether we have create a table. Click on the table and right-click the refresh, and you can say that actually we have created a customer dim table. And it has some columns, right? And you can say the surrogate key called customer dim ID, and the original key called the customer ID, right? Okay, so let's go back to this. And by using these two functions, you have input a CS file and convert the CS file into a dimensional table. and store the table into the PostgreSQL. And next, we need to save this. We need to run this transformation. Before that, you need to save this transformation. You can click the file and click save. And let's give it a name. For example, customer import transformation 2. And you can also click on the blank arrow to change the name. Or you can right click on the blank arrow and click the properties to set the name for the transformation. And now you can run this transformation to complete the transformation, because until now you should know that you only create a table. You didn't load the data into the customer dim table, right? And in order to run this transformation, you can click the action, click run, or you just click this button and click run. And you needn't to change any any options in this window. And then click run. And in the execution results tabs, you can say in the login tabs, you can say that I have the transformation has finished. And actually, we have read about 320 rows, right? And we have write these rows into this customer dimension lookup. So here the R means read and W means write. And let's go back to this. Go back to PostgreSQL to see whether we have downloaded this data successfully. We can right click this table, and then select view edit data, and we can say the first 100 rows. And you can say that we have actually successfully load the dimensional table into the PostgreSQL. And for each row in the dimension table, actually it has a surrogate key called customer dim ID, and also a version and the date from and the date to. And those three information are added by the, let's go back, are added by these options. And those fields are used to record the change information, change history of the data in the data warehouse, because a data warehouse need to handle all the changes in order to conduct the overlap analysis. So we need these three fields. And you can see the customer ID is the original business key in this table. So here, after we create the expected table and the dimension table, we will use the customer dim ID to connect or to map into the customer ID to find the tuples in this dimensional table. So and I should remind you that because we execute a SQL right here, so this means actually the essence of the ETL phase is actually performed by using the SQL. So what I mean is that of course you can write SQLs here to conduct the transformation to create the dim table, but with this software, with this graphical interface, this work is done more easily, right? But the essence is use SQL to create tables and to import data into the table. So, any questions about transform the original data source into a dimensional table? Okay. If you know questions, so here we have finished the transformation of the customer table, right? And because we star schema have several dimensional tables and the fact table, so we need to create other dimensional tables in the star schema. And I think the creation process is very similar, except the for the product promotion and the sales representative dimensional table, except the date dimensional table, because in the date dimensional table we need to create some hierarchies like the year, month, day, or the week, right? So I will show you how to create a date dimensional table. So let's create a new transformation. And first, let's input in the input tab folder, select the generate rows, and you can drag these functions into this. And double click that. We need to set the limit to, for example, to 1,100 to cover 3 years. And in the fields, we need to set the name as start data. We need to set first. And the type. And in the type, we need to select the date type. And the format, we can select format as this one. And in the value grouping, descending precision. Let's go. I need to check the previous. Yeah. Yes. Very. Let's close this. So in this transformation, we want to create the date dimensional table. So here we need to set the values. For example, because the orders in the source file are actually in this order file are actually only in the year of 2006 to 2008. Say, so it has a range of 3 years, and so we actually set the start value, start data as this first day of in the year of 2006, right? It should be commented with this format, and then when we can click OK, click preview, and sorry, and we can enter the numbers of rows we would like to preview and click OK, and you can see that we have you have created a list sequence of start date, and click OK, and next we need to, and the next we need to, maybe I can just use this to demonstrate you. This is a transformation that I have successfully create the dimensional table. And next we need to drag add data sequence. So this is you can search the keywords here, and you can just drag add sequence into this transformation. And then double click on the at the sequence. You can set the step name and specify the start value and incremental by 1. This is all the default values. You needn't to change anything. And then you need to add the calculator in the transformer. So in the transformer tab folders, you need to drag a calculator into this, and you need to set the fields as this. In the new fields, it is actually the cell. You can give it a new name as sales data, and in the calculation, you need to click this column and select the data A plus B. Data A plus B days, and in the fields A, it is actually the start date, right? And in the second field, it is actually the increment date field. So this increment date is actually set by the names of the value. So because we connect the input, the output of this step to this step, so this step will automatically find this value, find this field. So in the field B, you need to select the increment date, and the value type is date, right? And remove in the rem field, we need to select N, and the convention mask. In the convention mask, you need to specify the format of the data. So by this step, actually, so by the first 3 steps, actually, we have in the first step we generate a row, generate several rows, starting from a specific date, and then we add a date sequence, and then we calculate the sales date based on these 2 fields, right? And you can preview the date on each step. For example, you can preview the date in this step, and you can click in this step. You can click quick launch. And you can say, we have, this is the first step that we created. And this is the second add sequence step. We have add a column called the increment date. And then next step, we want to create plus this start date with this number to get a sequence of date. This is the logics behind those transformation. So in this step, we plus this start date with the increment date to get a new field called sales date, right? And then the next, because this output has several fields, so we want to only select the sales date column. So in the transform, select the select values, drag a select values functions to that, and double click this. And in the field's name, you need only input the sales date. If you click the get fields to select, you will get 3 fields, and you need to delete all the other 2, only and to preserve this sales date field, and then click OK. And then when you can right click this function and click preview, and then click quick launch to say, sorry, it is not possible to preview the select values at the current step. And next, you need to add the calculator. You need to add a calculator here. And change the step name, and then input some and input the new fields in this table. For example, you can click this and we can it has sales year. So this means we will create field which is the year of the sales, and in the calculation you can click this. You can click this and set and select the year of the date A, and click OK. And the field A is, you can select a sales date, sales date, and the value type is integer, and select, and right. This by doing this, you add a field of the year information about the order. So for example, if your data of the order is 2000, if the data of the order is this one, then you will get a 2008 in this field, right? And because I have added this value, so I will delete this. Console this. And finally, of course, you need to add in the data warehouse folder, you need to add the dimensional lookup update function, and you can click on this and change the name into, for example, into date dimensional update, and check this, update this dimension, and you can select the connection as before, or you can create a new connection and select the schema as public, and set the table name as date dim, and in the keys you need to set the field as sales data. This is the original key in the data source. We can check that. In this orders file, here we have the sorry. Sorry. So this is a sales data is the field that we created in the previous step, and the dimensional field is a field that we want to create in the dimensional table. And next, you need to in the fields click the get fields. You will get the fields that we created in the previous step, and then click SQL to execute the SQL, and you will get a table called a date dim table. And finally, you can conduct the transformation by run this transformation, and you will get a date dim table. Let's say in another database called order entry. So here I have created this table called date dim. Let's check the first 100 rows. And you can say in this table, actually we have create some sales date start from 2006 to until the 2008 for each day. And for example, for this date, actually the sales day of the year is the second day, right? And the sales month is the first month. Sales year is 2006, and the sales quarter is the first quarter. And actually, you can add as many as possible of the fields that you want in the dimensional table. So this is a transformation for conduct for generate the data dimensional. So do you have any questions?
Oh, I found some chart before I found some chart information is Suxun. I think Suxun previous share us with some file with some image shows the Postgre file download from their website cannot be installed. Suxun, have you any explanation about your questions?
Yes, I downloaded their installation files from their website twice, but both files I downloaded from their website cannot be installed, and weird error information.
So if you cannot install the PostgreSQL from the website of the tutorial, I recommend you to download another installer from the official website of PostgreSQL.
Yes, so I download new files from their own website, but also cannot be installed. I will try. Let's try a different version.
So what is the versions that you download? Is 10 or the latest version?
I download the latest version and the version before the latest version. They both can't be installed. The error information are very same. It's some weird characters. I can't read it.
So in this sorry. So in this page, you can say that the installer by the Windows system. So actually, the official document says that the Windows 10 versions can only support the PostgreSQL version below 11. So I don't know. I haven't tried the latest version. For example, the 14 version in the Windows 10 system. So if you cannot install the latest, I recommend you install, for example, the 10 version for the PostgreSQL.
Okay. Thank you.
Yeah, because it says the Windows 10 are not shown in these higher versions.
Okay, thank you.
Okay, so let me check other problems.
Yeah, and I say other two also some problem. Anyone else have the issue with Linux with the CSV file browsing in Spoon? Okay. Yeah.
So do you mean you have some problems when loading the CS file into Spoon in Linux system?
Oh, I see his answer. He say he can use the absolute path.
Yes.
Yeah.
Yes. You can say that, for example, in this. So in this file name, if you browse, actually you can use the absolutely path or the referential path. So if you cannot work, I recommend you use absolute path in this file name. Okay, let's see other questions. Anyone else has issues with Linux with files? Yeah. With iCheck browse it shows sweet part using that. Yeah. Okay. So this is the transformation for generate the data dimensional table and the customer dimensional table. So you need to complete other dimension table. For example, a product dimension table. This is very similar to the customer dimension table. You need to input the CS file and add a dimension lookup date and connect this to functions. And of course, the promotion dimensional table and the sales representative dimensional table. And finally, after you have after you have created all the dimensional tables, the next step is to create the factor table, right? The factor table will based on the dimensional tables that you created in the previous step. So in order to generate a factor table, first you need to, of course, you need to drag a sales file input. And then in the sales file input, you need to browse and check the order sales file as the input. So this is this step. So actually, I have here. You can say that this is absolute parse. And in this file, you need to pay attention to this field called order date. So you need to change the types to date, because when you click get fields, this type may have some, well, may be wrong, maybe have a wrong type. So you need to change this type to date, and you need to specify the format. For example, in the order export file, the order date actually has this kind of format. So it has 3 letters for the month. So you need to change the format as this DD and 3 M letters, right? And then you can you can click OK, we'll preview this data. And after that, you need to add a dimensional or dimension lookup update into as the input to connect to the order sales file input. And this is different from the previous step that we are used to create the dimensional table. You need to uncheck this option, because here we needn't want to update the dimension. We only want to look up the dimension table into to the factor table, and you need to uncheck this enable the cache, and in the fields, in the keys, in the fields in stream, this is the original keys in the order export CSV file, and the dimensional field is a field in the dimensional table, right? And you also need to set the surrogate key or the technical key here, and you needed to get all the fields, and then click, and if you uncheck this update dimension, so the SQL button is become unavailable. So you can click. You needn't to execute any SQL queries. You just click OK, and similarly, add the other dimensional tables lookup. Please remember to uncheck the update in dimension, and create a connection to the database that you store the dimensional table, and select the start schema, and then select the dimensional table, and then set the keys in the building stream, which is in the original data source, and the dimensional field in the dimensional table, and set the surrogate key, and then click OK. It is similar. It is very similar for the next step, right? But in the data dimension lookup, you need to pay attention to the fields, because in the field in stream, you need to set as order data. Why? This is because in the original files, the field is called order date, but in the dimensional table, right? The keys is called a sales date. So you should pay attention to that. If you set the wrong field, you cannot create the correct fact table. And in the surrogate key, set as the date dim ID, and then click OK to complete this. And after that, you need to add a calculation. You need to add a calculation in the transform tabs, calculate, drag a calculate here, and connect the output to this step. And in this window, you need to create 2 measures in the fact table. So the first measure is the amount sold. So it is actually just a copy. You just create a copy from the field called quantity. So you can say that in the order export file, actually we have a field called quantity. This is the amount sold for each order, right? And besides that, we also have a field called unit price. So based on these two fields, we can create 2 measures. The first measure is the amount sold. So this is just a copy, and from the field quantity, you can select the field as from quantity and set the values type as number and the remove to as not. And then you need to create another measure called the dollars sold. So this is actually a calculation A times B from the field A and B. So in the field A, you can select the unit price, and in the field B, you need to select the quantity and select the values as number and they remove N. So by doing that, by doing this calculation, actually for each rows in the original order table, you create a dollars sold by times these 2 fields, right? And then finally click OK to set the measures. So now you have get all the dimensional lookup and set the measures. And finally, of course, you need to store the tables into the PostgreSQL. And in the output folder, drag a table output here. And you need to specify the information. For example, you need to create a new connection to the database that you want to connect, and select the schema and specify a target name for the fact table as sales fact. And you need to remember to check this specified database field. And then in the database field, you need to click get fields, and after you get the fields, you will get many fields, and you need to just remember to just remain those fields and delete other fields. In these fields, order ID is the keys for this table, and the custom dim ID, sales dim ID, product dim ID, promotion dim ID, and date dim ID are the surrogate keys that we will use to connect to the dimensional table. And the dollar sold and the amount sold are actually the measures in the fact table. So actually, you can say that you need to remove other fields like the order date, customer ID, and the promotion ID, and the sales rep ID, right? You need to only preserve those fields and click OK, and then click the circle and execute the circle. You will create a table named sales fact, and then run this transformation to complete all the process. After that, you will get a table. You will get a table called the sales fact. So let's review the first 100 rows. You can say that for each ID, for each order, actually we have create tuples in the factor table. So the factor table has some foreign keys. So this is foreign keys to the dimensional table, and we also have like 2 measures.
Yeah.
So any questions? Okay, so until now you have created several transformations to create the factor table and the dimensional table. Next, you can create a job. For example, click the new and the job to accommodate all these transformations in a sequence. For example, in the general, you can drag a start and also drag a transformation and connect the start to the transformation. So double click on the start. You can set for example, you can set the jobs as repeat, and we will set it as daily. And for example, we can set it as in the 12th of every day. It will start this job, and in the transformation, for example, we can set as customer transformation, and in the browser, select a file, select the transformation file. For example, we can select those transformation file, and in this, and finally, you can run this job, right? But between those steps and the transformation step, actually, you can add other validation and the checks. For example, in the file manager, you can add a check to wait for the file. This means you will wait for the file to be saved and unupdated. Until that, you will conduct the transformation. Of course, you can add other validation. For example, for the condition, you can check a database connection. You can check whether you have a stable or a successful connection to the order example database, right? Because unless you have a correct connection, you can conduct the transformation and store the data into the table, right? So for example, we can click. You can first check the database connection and check the wait for the file. And you can also check whether the file is locked or the file exists, right? You can do all this. And finally, you need to save these jobs in your machine and run these jobs. So here I just add one transformation. You can add more transformations as the output of the transformation as a sequence in the jobs. So in the exercise, I want you to create several transformation for each day creation of the tables. And I require you to create a job to accommodate all those transformations in one job. And you need to add some check and validations So we will not save this. So this is all for the creation of the factor table and the dimensional table. So actually, I didn't show you how to conduct other tasks in the ETL. For example, to clean the data by remove the missing data or by remove the redundant data or the inconstant data. So here we just focus on how to create the effect and the dimensional table. So if you can successfully create a star schema, you will get these 6 tables: 5-dimensional table and 1 fact table. Okay, if there are no questions, maybe we can have a 5-minute break. And after that, I will introduce how to create a lab cubes using the schema workbench. So let's back at about 5 minutes later.
Okay, thank you. Yes, yes. So we will start at 1:36. 5 minutes.
Okay, 1:36.
Okay, thank you.
Hello, everyone. Welcome back to this meeting. So I saw some questions.
I just show a post and in the next Friday meeting we will also arrange some time to handle this hands-on the discussion.
Okay.
Yeah, because on the next Friday we will first give some tutorial. Then after that we can also continue the discussion about this hands-on issues.
Okay, so let's continue with our. Let me share my screen. So until now, you should understand that we have what we are now. We are input the source data source and create a star schema and store this star schema as 6 tables in the database, right? And in the next step, we need to conduct the overlap analysis. We can just write some SQL queries based on the star schema, right? Use such as the group by or the cube or the roll up operators. But in a different way, we will use because we use the Pentaho to build a data warehouse. So next, we need to build a overlap schema or overlap cube based on the star schema that we are created before. So first, you need to open the schema workbench software. And the next step, click the option. Click the option menu and click connection. Sorry, it is just so in the Windows you can create a database connection. For example, I have created a connection called the order entry connection, and you use a PostgreSQL, and I set the host name as localhost, and the database name is this database order entry, right? And they set the port number, username, and the password, and then click test to test the connection. If you can say this message box, it means you have successfully created a connection. And click OK, and then click OK. And before that, you can explore the database by click file new JDBC Explorer, or just click this icon by click JDBC Explorer, and you can say that in this window, actually we have get all the schemas in this connection, right? We connect the JDBC with the PostgreSQL in the database called order entry. And in the public schema, you can say that we have obtained the 6 tables. And you can right click, for example, the customer dim table. You can click and get the fields of this table. And then we can close this. And in order to close, in order to create schema, click this and click schema. You will open a window like that. And in the left window, right click the schema and click add cubes. or you can just add this icon. It has the same function to add cube. So you can specify name for the schema. For example, you can create a order OLAP schema, and in the for the cubes, you need to create a add dimension. Sorry, not add dimension. You need to add table, and this in the schema, you need to select the public, and select the fact table, sales fact, right? And you can also give this cube a name. Let's call it cube 1. And after that, you need to create add measures. You can add 2 measures, right? The first measure is say amount, which we will use say some aggregator in the column amount sold, right? This is a measure that we are created using the PDI software, and you can select the data type as number, numeric, and you can also set other attributes. For example, the photo or the captions, and make the visible check. And next, let's add another measure called the dollars. And the aggregation is also the sum aggregation, and let's choose say dollar sold column as a column which we want to conduct the aggregation. And the data type is also numeric. And after that, you need to click the schema and click add dimension. Right? For first, we want to add for example, the name as data dimension. And in the second is as for example, the customer dimension. Third is a product dimension. So first, let's go back to the data dimension. In data dimension, you need to create the hierarchies. For example, in the hierarchy, let's click the add table, and because in this we will use the date dim table, so select the schema public and select the date dim table, right? And in the and click the hierarchy. Let's call it time hierarchy. And right click this button, add levels. So the first level is called the year, right? So the table here is a public dim, and where you will use a column from the sales year, and the type is a integer, right? Because the year is integer, and in the level type, we'll choose time years, and hidden choose never, hidden member if choose never. Let's check. Yeah, then you will then you have set all the information about this year hierarchy, and for the next hierarchy, we set it as months. Similarly, we need to choose a table to the date dim, and the column is a sales months, right? And the type is integer, and the internal type. Oh, no, and the level type is a time month, and finally is a hide member if choose never. And of course, we can also choose. We can also set the day, right? Similarly, we can select other the dim column as sales day of the year, and the type is integer, and the level type is time days. You can create other hierarchies in the time hierarchy. For example, the quarter or the weeks, which is very similar as this one, right? So you need to specify the foreign key because here we will use the date key. So the foreign key is actually the date dim ID, right? But if you not specify the foreign key, it will automatically find the foreign key based on the structure of your factor table and the date dim table. It is okay if you don't specify the foreign key. And next, we can, of course, you can create several hierarchies in the same data dimension. For example, you can create another hierarchy, and this hierarchy you can add tables and then create other hierarchy. For example, year, week, such as that. Here we will just delete this. And next, after you create this data dimension, you need to use this dimension in this cube, right? In this cube. And in order to use this dimension, called data dimension, right-click this and add the dimensional usage. And you can give it name as data dimensional usage. And the source, in the source, you need to select the data dimension, right? Because here we have three selections. Because we create three dimensions, right? Select the data dimension, and then choose the. I guess you need to set other fields. So the foreign key actually is the data dim ID, right? As we said before. And this is the how to create the cubes using the factor table, the measures, and the dimension. Similarly, you can create other dimension. For example, the cost dimension by click this and add tables. Here, you can collect the public table and the public schema under the customer dim table. And for the hierarchy, you can it as a region hierarchy, right? And then add levels. So the first level we can call it country. So the country information about this customer. And the second we can call it the city. Let's delete this. And for the first country, you can also select the table. This is from the custom dim, and the column is you can select the country ID or the country name. Here we will select, for example, we can select country ID, and the type actually is string type. You need to check these types of each attribute in the table, and the level type is not times, right? So for other level type, we will all choose as regular type, except the data dimension. For the cost dimension and the product dimension, we will select regular type. And hide member if we select never. So and similarly for the city in the hierarchy, we can select the table and the column as city, and the type as string, and the level type as regular, and hidden if as never. So by that, we have created a customer dimension, and after that we can add a dimensional usage in this cube, and we can call it as customer usage. And the foreign key is of course the customer dim ID, and the source is the customer dimension that we are created here. So this is all about how to create a OLAP cubes based on the schema. So you need to remember that first you need to make a connection to the database where you store the factor table and the dimensional tables. After that, you need to create cubes and input the factor table and create the dimensional usage and the measures. So this is about how to create an OLAP schema. And I will show you that I have create a schema. So this is schema that I created before. I create three dimensions here, and in each dimension, for example, in the date dimension, I create a date hierarchy. The hierarchy is from the year to the quarter, to the month and to the day. And in the customer dimension, I create a ranging hierarchy from the country to the city. Yes, I think maybe I forget to set the primary key in this yes, here for example for the date hierarchy, I need to set the primary key. So the primary key in the date dimension is a sales is a date dim ID, right? So this is for a primary key in the date dimension. So I forget to set that. Sorry. So you also need to add the primary key in each hierarchy in the customer dimension and the product dimension. I'm sorry for that. So let's go back to this dimension, to this schema and OLAP cubes. So after you create the OLAP cubes, you can store the OLAP the cubes as a XML file format in your local machine. For example, here I have created as a OLAP cube .xml file format in my computer. And finally, the last step is to publish your OLAP cubes on the Pentaho server. To do that, you can click the file and click publish. So in this window, you need to input the address of the server. I guess it will automatically show this, and you need to input the user name and the password, and you can specify a name for the data source. For example, here I set a name called odd entry data warehouse, and finally click publish, and you will publish the schema on the server. Because I have published the schema on the server, so I'll not publish again, because I will overwrite the schema in the Pentaho server. So after you publish, you can you can start the Pentaho server to conduct the final analysis. So by start up the Pentaho server, you need to go to the you need to go to the directory, the Pentel server installation directory, and click the start Pentel file or the start Pentel .sh script in Unix system, and you will create. Sorry, I see some questions. Will we address technical issues too?
I think Mohan maybe ask if we will address technical issue on next Friday. Yeah, I think if you have some particular technical issue, then I suggest you first ask in the Telegram. Then we can also answer on next Friday. Yeah, but if we cannot answer Friday, you can also send us some email. Yeah, then we can make some appointment for you. Yeah, because I don't think on the next Friday meeting we can solve all the problem. Yeah, because some technical issue will take some time. Yeah, to solve. Yeah, it will be not very practical. Yeah, to solve all the problem only in one meeting, because in the next week we maybe only have less half an hour for this hands-on session. Yeah, because I will first give a tutorial. Yeah, we will discuss some other problem together. Yeah, so the time is very limited on next Friday as well. Yeah, so you can first ask in Telegram. Yeah, if not, then you can send us an email. Yeah, we can make some special arrangement, I think. Oh yeah, I see another question about the data line. Yeah, for the data line is I said it's April 14. Yeah, so you still have 3 weeks. Yeah, to solve all this exercise 1. Yeah, because I know that April 15 is some holiday, right? Yeah, so I said it's April 14. You have 2 weeks. Yeah, and another question is when to expect the recording. Yeah, so yeah,
so I will upload the recording maybe just in the day, and I will send you a link, and I put link on the link on the GitHub page, and you can review the video to learn how to create the transformation or the jobs to conduct the ETL tasks. So maybe it will need some time to start up the server, the Pentel server. Usually it will require 7 to 10 minutes. So at this time, if you have any questions, you can ask me about the installation or the. Maybe I can give a short description about the exercise that you need to complete. So the exercise has 20 points. So in the first part, you need to build a DW&BI project. So first is using the Pentel data integration to complete the ETL processing. So in the first step, you need to create a star schema, and then output these tables in PostgreSQL, right? So to do that, you need to create a database in the advance in PostgreSQL in order to create a connection. And you need to create, and this star schema will include a factor table called sales fact, and the 5-dimensional tables, for example, the customer dim, date dim, and the 2 measures. I think these are covered in this tutorial. And I have some requirements in the date dimension. Because, for example, you need to add those attributes. For example, the sales year is the year of the date, sales quarter, sales month, and the sales day of month. you should pay attention to the difference between the sales day of year and the sales day of month, because the sales day of month will be accounted from the 1 to the maybe 365, but the sales day of month is actually a number from 1 to 13, right? So which day in the month? So in the next month, you will compute this this field start from 1 again. And the sales day of week is actually a number between 1 and 7, right? And the sales week a year is the same. And the sales week of quarter, you need to add those attributes and conduct, because this shows the flexibility about the dimensional analysis. You can add as much as attributes in the dimensional table to conduct the analysis. And in each attributes, actually you have a different view of your data, right? And the tips is to create. Sorry.
So yeah, so yeah, we already run out of our time. Yeah, it's
okay. Okay, maybe we stop here.
Yeah, you can stop here and we will discuss next Friday. Yeah.
Okay. Okay.
Yeah, because it's already past 2. Yeah.
Okay. Okay. Thank you. Thank you for your participation.
Yeah, I will close this session. Yes, and but if you have some question, you want to ask now, I think we will also be here, to answer your questions. Yeah, okay, yeah. See you in next Wednesday meeting. Okay, bye bye.
Thank you. Bye bye.
Thanks. Bye.
Thank you. Bye bye. Have a nice weekend.
Yeah.
You too.
If you want to ask some question now, then it's also fine, I think. Sammy, have you any questions so far? Yeah, maybe Sammy is not online.
Maybe I will close.
Okay, yeah. So maybe we can end this meeting.
Meeting. Okay.
I think you can continue this explanation about this exercise on next Friday. Yeah, I will give you about half an hour. Yeah. Or
So I think I didn't need a half an hour. I need only 15 minutes.
Yeah, maybe 20 minutes. Yes, and
okay.
You can discuss. Yeah, I will first host this tutorial. Yes, then
okay.
we can discuss this or questions. Okay, good.
Okay, thank you. Thank you.
Bye bye.